Question 10. When log y is plotted against x squared, a straight line graph is obtained which passes through the points 2, 4, and 6, 16. Part 1. Show that y equals to 10 to the power of a plus bx squared, where a and b are constants. So first, to do this question, you have to know that since the question says it is a straight line graph, an equation of a straight line graph will be y equals to mx plus c. In this case, y is the log y, m is the gradient, x is x squared, and c is the y-intercept. And now if you just get the gradient and the y-intercept, then you get the answer. So basically from here you just have to get your gradient. So the 2 points are 2, 4 and 6, 16. So the gradient will be gradient equals to y1 minus y2 over x1 minus x2. So in this case it is 4 minus 16 and 6 and it's 2 minus 6. 2 minus 6. And now if you simplify this, it gives you 4 minus 16 divided by 2 minus 6, 3. So the answer will be 3. The gradient is 3. And now your y-intercept, to get this value, you have to first substitute the gradient inside the straight line equation, which is y equals to mx plus c. So y equals to 3x plus c. And then from here, you just have to sub in one of the coordinates, either 2, 4 or 6, 16 into the x and y values. So let's go for 2, 4. So since x is 2 and y is 4, we write 4 equals to 3 times 2 plus c. And now we can get our y-intercept, which is c. So you can get 4 minus 6 and you get minus 2. So now y equals to 3x minus 2. And now from here, we know that y is log y and x is x squared. So from here we can just substitute both of these values inside. So that we get log y equals to 3x squared minus 2. And now from here we can make this into a y. We can make this the y. We can make y the subject by we can make y the subject by first lg or log can also mean log to the base of 10. And now if you want to make y the subject, you just have to make this whole equation to the power of 10. So it becomes 10 to the power of 3x squared minus 2. So after you get this equation, you have to get your a and b values, which you can see in the question right here. So from here, the original equation is y equals to 10a plus bx squared. But right now here it is 10 to the power of 3x squared minus 2. So if you rewrite this equation, it becomes 10 to the power of bx squared plus a. So from here, if you compare these two equations, your a value will be minus 2 and your b value will be 3. Part 2. Find y when x equals to 1 over square root of 3. So now we know that y equals to 10 to the power of 3x squared minus 2. When x equals to 1 over square root 3, y would equals to 10 to the power of 3 and 1 over square root 3 squared minus 2. So this becomes y equals to 10 to the power of 3 times, what is 1 over square root 3 squared? That would be 1 over 3 minus 2. This becomes 3 times 1 over 3 will be 1 minus 2. So it becomes 10 to the power of minus 1. So that this becomes 1 over 10. So the answer is 1 over 10. Part 3. Find the positive value of x when y equals to 2. This is simple, so you just have to equate the equation y equals to 10 to the power of 3x squared minus 2. So now in this case, when y equals to 2, you have to solve for x. So when y equals to 2, this is 10 to the power of 3x squared minus 2. And now you can log both sides, so that it becomes log to the base 2 and log 2 and log 10 3x squared minus 2. So this LG here, it means log to the base 10, as I've said in this equation here. So from here you can do log 2 equals to 3x squared minus 2 times log 10, as the power of a number in a logarithmic function can be brought down and be written like this. And now since log 10 is 1, this whole equation becomes log 2 equals to 3x squared minus 2 times 1. So it becomes just log 2 equals to 3x squared minus 2. And from here you get 3x squared equals to log 2 plus 2, and x squared equals to log 2 plus 2 over 3. And now from here you can get your x value, which is x equals to square root of log 2 plus 2 over 3. Remember, this said the positive value of x. So from here, do not write plus and plus or minus, as if you write that, you'll be counted as wrong. So you can leave your answer as this, or you can either simplify it so that it becomes 3 significant figures. Since the question did not ask for an exact value of x. So now your x equals to square root of log 2 plus 2 divided by 3, which is 0.876, around there. So this is your answer. Question 11. It is given that y equals to x squared plus 1 bracket 2x minus 3 bracket to the power of half. Part 1. Show that dy dx equals to px squared plus qx plus 1 divided by 2x minus 3 bracket to the power of half, where p and q are integers. So first, to do this question, you have to know the product rule, which is dy dx equals to v du dx plus u dv dx. So since y equals to x squared plus 1, 2x minus 3 to the power of half, in this question, we let v equals to x squared plus 1 and u equals to 2x minus 3 to the power of half. And now we can get our dv dx, which is 2x, and our du dx value. So when you get dv dx, it is basically differentiating the v value that you have just got. So it's differentiating this equation, and for this one, you're differentiating this equation here. So first, to differentiate the equation, you have to move the power down and times the value by the power, and then you have to subtract 1 from the power, and then here now you just have to, for this kind of differentiation, you have to also differentiate the value inside of the bracket. So you have to differentiate 2x minus 3 also. So if you differentiate 2x minus 3, you get 2. So now if you just cancel this out, your answer will just be 2x minus 3 to the power of negative half. And now from here, you can get your dy dx. So dy dx equals to v times du dx plus u times dv dx, which is 2x. And now if we simplify this, you get x squared plus 1 times 1 over 2x minus 3 to the power of half plus 2x minus 3 to the power of half. And now from here, you can just simplify this so that it becomes 2x minus 3 to the power of half, x squared plus 1 plus 2x minus 3 to the power of half. And from here, things may look complicated because there is something to the power of half and 2x minus 3 to the power of half. So if this looks complicated to you, you can make it simpler by saying let 2x minus 3 to the power of half become a. So that dy dx will now become x squared plus 1 divided by a plus 2xa. And now you can make the denominators all the same. So you times a to this. So it becomes x squared plus 1 plus 2xa squared. So the whole thing divided by a. And now if you substitute the a values, you get 2x minus 3 to the power of half, x squared plus 1 plus 2x times 2x minus 3 to the power of half, the whole thing squared, just like that. And now if I simplify this, you get x squared plus 1 plus 2x times 2x minus 3 divided by 2x minus 3 to the power of half. So from here, you can just expand this equation so that you can get x squared plus 1 plus 4x squared minus 6x divided by 2x minus 3 to the power of half. Just like that. And now from here, if you simplify this equation, you get 5x squared minus 6x plus 1 divided by 2x minus 3 to the power of half. And that is your answer, which is dy dx. Part 2. Hence find the equation of the normal to the curve y equals 2 x squared plus 1 bracket 2x minus 3 bracket to the power of half at the point where x equals to 2, giving an answer in the form ax plus by plus c equals to 0, where a and b and c are integers. So for this question, it says find the equation of the normal to the curve. So this is the equation of the curve. So just now, we have found the dy dx value of this curve, which was dy dx equals to 5x squared minus 6x plus 1 divided by 2x minus 3 to the power of half. So this dy dx, it can also be referred to as the gradient function, as if you differentiate an equation of a graph and then you sub in any x values inside, then you get the gradient of that point, the exact gradient of that point of the x value that you have just put inside. So for this equation, I will show you the gradient of this graph at where x equals to 2. So the gradient will be when x equals to 2, you have to sub the x value inside the dy dx, so that it will be 5 times 2 squared minus 6 times 2 plus 1, 2 times 2 minus 3 to the power of half. And then from here, if you simplify this, you'll get 5 times 4 minus 12 plus 1 bracket 4 minus 3 to the power of half. And from here you'll get 20 plus 3, 4 minus 3 is 1, and 1 to the power of half. And now you'll get just 23. So when x equals to 2, the gradient of the graph will be 23 for this graph right here. So the equation of the graph, or the also known as the tangent of the graph at when x equals to 2, would be y minus y1 equals to the gradient times x minus x1. And now you can see that there's a problem because we don't know what coordinates are the x and y values. Well, we know the x value because we have substituted the x as x equals to 2. So x is 2. So how do you get the y value? To get the y value, you can just substitute the x, which is 2, inside the original equation, y equals to x squared plus 1 bracket 2x minus 3 bracket to the power of half. So what I mean by that is, you can just substitute the value inside the original equation, just like that. So they can get 4 plus 1, 4 minus 3 to the power of half. So this will be 5, as 4 minus 3 will be 1, and 1 to the power of half will still be 1. So the answer is 5. The coordinate we're looking at is 2, 5. So the equation of the tangent will become y minus 5 equals to 23 x minus 2. Remember, this is the tangent, not the normal. So from here you can simplify this so that it becomes 23x minus 46 plus 5. So that just becomes 41. And now from here you have to get the equation of the normal of the graph. The normal is when the gradient, so let's say there's a graph here like that, and if there's a point here, the straight line which touches only one point of the curve is called the tangent. And the line which is perpendicular or 90 degrees to the tangent is called the normal, and it also passes through the curve at the same point as the tangent. So this is called the normal. So how do you get the equation of the normal? So from this you can already see that the gradient of the normal would be perpendicular to the gradient of the tangent. So there's an equation for that, where m1 times m2 equals to -1. This is when two perpendicular graphs or lines, two perpendicular lines, and their gradients are 90 degrees to each other. Then if you multiply them together, you will get -1. So since the gradient of the tangent is 23, you get 23 times m equals to -1. So m2 will become -1/23. So this is your gradient of the normal. So now finally, to get the equation of the normal, the equation of the normal will be the same as, similar to the tangent. So it will be y minus y1 equals to -1/23 times x minus x1. And now, as I just told you, the normal and the tangent, they will cross the curve at the same point. So since the tangent crosses the point at the curve at the coordinates 2, 5, the normal will do the same. So now you can just substitute the normal and the x and y values inside the equation of the normal, so that you get y minus 5 equals to -1/23 times x minus 2. And now you get y equals to -1/23 x plus 2/23 plus 5. Now from here you can just simplify this, so that you get -1/23x plus 2/23 plus 5, which will give you 117 divided by 23. 117 divided by 23. We are not done yet, as the question said, giving your answer in the form ax plus by plus c equals to 0. So we have to get rid of the fractions and make it as a whole number. Get rid of the fractions and make it as a whole number. So to do that, you have to first times 23 to both sides. So you times 23 here, then you times 23 here, so that it becomes 23y equals to minus x plus 817. And now from here you can just copy the equation which the question said. So it says put in the form, first the x, then the y, then the c. So from here you can just do x, then the y, then the c equals to 0. So now your a value will be 1, and your b value will be 23, and your c value will be -117. So this is the end of the paper 0606, paper 1, May June 2019.